In this video, I will show you how to compute the inter-arrival time and the processing time, as well as how to create a histogram chart for those special data. And you can use this approach for descriptive modeling step and for verification step. So for descriptive modeling step, you need to collect the data. And based on the data you have on customer arrival or processing time of the activity, you should fit a distribution for the data. And that is for descriptive modeling. And for verification step, imagine this is your final model, but you need to verify if what you have built in the model is exactly the same as what you described after you collect the data. All right. Now let's focus on the inter-arrival time first. So first, we need to run the model and save the output into the CSV file. And remember to save the output, you go to the endpoint, tick on File, and choose the name and remember the location where you save a file. And after that, just go to the location where you saved the output and open the output file. All right, so right here, we have this column. This column is the time in when the customer enter into our property or facility, for instance. All right. And to compute the inter-arrival time, we need to take the difference between two consecutive customer arrival time. So for instance, the inter-arrival time for the second customer will be the difference between their time in and the previous customer time in. So basically, that is the difference between this cell and the above cell. All right, and we can copy the formula for all of customers. All right, and definitely the inter-arrival time for customer one is 0. So now, based on this column, you can create a histogram chart. You go to Insert and go to Recommend Chart and choose Histogram and click OK. That's it. Now you can see the shape of the distribution, and you need to check back what you described in descriptive modeling stage. So you can go to customer arrival, and in the descriptive modeling stage, you already identify your data follow an average distributions with 5 minutes average parameters. Okay. So based on this data, you can see the inter-arrival time, not exactly 5 minutes, but you can see 4.6, 6, 5.55, 5.7, 4.1, 5.3, 6.75. So basically, this is around 5, right? And let's call it inter-arrival time. So based on this distribution, you need to use your statistical knowledge to verify whether the shape of these distributions follow exactly the average distribution or not. You can go to Simulate and Help you can go to simulate search bar and search for all the information regarding distributions. And of course, you have a lot of other resources about distribution, so you should utilize the resources. I can type average distribution. And here we are. Right here, you can see the definitions of average distributions. And you also can explore other distribution in Simulate as well. We just computed the inter-arrival time. Now, let's compute another measure called processing time. To compute the processing time, we need to capture the time when the work item enters into the activity and the time when the work item is completed at the activity and leave the activity. And having said that, we need two types of time measures. So we need to create two new variables. Okay. So the first variables, we call it activity start processing. And let's create another variable called activity start processing. All right. We need to have some adjustment for the routing in and routing out so we can capture the required time for start and stop processing for this activity. We double click on activity 1, go to routing in and go to options. And right here, we should choose after the work item is loaded on the activity 1. And we search for the set function. In the set function, we would like to specify our created variable called start processing. Double click on this one, equal to the current simulation time at this point. So basically, we click right here. We go to other global data and choose simulation time. That's it. All right. And we just capture the time when the work item enter into the activity. Now we need to capture the time when the work item leave the activity. So double click on activity 1, routine out, and go to more. And on the work complete, very similar. You choose the set function. And right here, we would like to specify our label called the activity stop processing equal to the current simulation time at that point. Go to other logbook data, choose simulation time, and we click OK. And that's it. So we should run the model one more time. And then we go to the output file. And right here, we have two new columns. The first column called activity start processing and the activity called activity stop processing. And we need to compute the processing time. The processing time is the difference between the activity stop processing and the activity start processing time. All right. So based on this new data, we can verify if the model built is exactly the same what we described in the descriptive modeling stage. And to do that, we can go back to the activity itself. And we see the distribution we specify is triangular distribution with parameter of 2, 5, and 7. So we can look at the data again. So you see the data is exactly around 2, 5, and 7. Okay, so 2 is the lower bound, 7 is the upper bound, and 5 is the most likely values. All right, and similar to the inter-arrival time, we also can create a histogram chart for this column. We go to Insert, Recommended Charts, and choose Histogram. And we can specify here is the processing time. So again, you need to use your statistical knowledge to justify the shape of distribution is really triangular distribution or not. And you can use the help function on Simulate software. You go to help and help file. Right here, you can type triangular distribution. Here we are. Okay, I just show you the step how to verify it, what you built versus what you describe in the descriptive modeling stage. But in practice, when you collect the data, you didn't have any distribution specification yet. The procedure to compute inter-arrival time and processing time is quite similar. For instance, you collect data for customer one when they did arrive. When did second customer arrive, you take the difference, you got the inter-arrival time and do the same for the rest of the customer. Similarly, you capture the data, the time data on the activity when it starts for the first customer and when it stops for the first customer. You take the difference between two of them and you will get the processing time of that activity for the first customer. And you will do the same for the other customers.